we deployed AutoMQ on our EC2s. I mirrored all the traffic from our CDC warehouse cluster, and I watched the cost in S3. And it was like 17, 20 times less than our kind of like AWS cost. And then I showed it, and everybody's kind of like, wow, well, that's the thing.
That's Anton Borisov, principal data engineer at Fresha. But let me rewind, because before any of this, their entire data stack was Postgres, Kafka, Debezium, and Snowflake. And their homepage analytics, hooked directly into Postgres, was timing out.
I just tried Docker container, and I showed to Emiliana, our head of data engineering, and he kind of like, okay, what is it? And I said, like, don't you see? I'm using MySQL protocol, like driver, to connect to some modern analytical database. And I said, like, imagine what if you would kind of like build this solution, and we say like, Teams, you don't need to actually learn anything like new to introduce like lakehouse driver or whatever. You just need to have like MySQL driver. You write SQL query, and suddenly it magically works. And I think like it was only like 3 weeks until we actually thought like, okay, StarRocks is actually a good idea. Because our biggest fear was, okay, would it be hard to deploy with Katies? And then there is an operator. So once we tried and queries worked, we said like, okay.
1 day to try it out, 3 weeks to properly evaluate, a few more to bring it to production. And that gave them the mandate to build the rest. Flink, Spark, Iceberg, Lakekeeper, a composable data platform where when the next problem comes, they don't say no, they say
yes, but imagine I have like 20 different pipelines and all of them kind of like need booking stable. So you know the stories that I need literally kind of like is this booking stable in every kind of like state. For every single pipeline.
You cannot share state between Flink jobs, right? That's the core issue.
Yes.
That Fluss is...
It's internal.
Yeah, and with Fluss, you externalize it and all of the jobs can work on the same Fluss table, right?
Yes, exactly.
StarRocks in production, AutoMQ on deck, Fluss and Feldera on the horizon. The story of a small team that rebuilt their entire data platform into one of the most modern data stacks out there in less than a year. Welcome to the next episode of Upstream. Welcome, Anton. Thanks a lot for being here. Today we will talk about what's going on in Fresha, because you've been publishing about this for at least a few months, and I've seen that you've started talking about this as well. I've seen that StarRocks is milking your use case for all it's worth, and it's a fantastic case study. And I mean, for the benefit of not only StarRocks, of course, but everyone that wants to understand what's going on in the bleeding edge. What's fascinating for me is that you are doing this transformation and introducing a lot of interesting technologies, but this transformation is coming for a reason. What I would like to understand is what was the context in the beginning, what problems were you facing, what problems were you trying to solve, and why have you chosen the way that you have chosen, so that first of all we can understand what's happening, but second that the audience can understand and maybe learn on how to what to expect when you are attempting something so big, and the lessons you have learned along the way. So thank you very much for coming, and welcome.
Okay, thank you for the introduction, Jan. It's a pleasure to come and talk with you and share some interesting stuff that's happening at Fresha right at the moment or in the nearest future. So, but let's get back to our kind of like new modern data architecture and StarRocks. I mean, like StarRocks is not the whole story; it's a part of the story. But basically, it started like super simple. So, data engineering team at Fresha is very small, so not so many people. And before it was kind of like, okay, we have a lot of databases, like Postgres databases. So we have Debezium. We get like the data into our Kafka CDC data, and then we just send it to Snowflake. That was the whole data engineering at Fresha. I mean, like
right.
For most of the use cases, it's kind of like fine, because what is basically Fresha? It's kind of like a marketplace for kind of like beauty and healthcare. So you want to get a haircut, you go to Fresha, you search, then you kind of like make a reservation, and then you come. So it's kind of like a customer story. But to this story is also kind of like a provider story, like a partner. And partner wants to understand like what's happening with the business. So it needs some kind of like analytics, some aggregations, some kind of like monthly comparisons and other stuff. And for this, kind of like solution like Snowflake is actually pretty decent until you want to kind of like get some widgets to make it more interactive and kind of like more responsive. Because there is like, for example, homepage homepage with some dashboards and widgets. And if you kind of like tell that, oh, actually your widgets are updated once in 20 minutes, it doesn't feel like a good solution, at least in terms of user experience. So that was kind of like the first challenge, because Snowflake works, but you need to kind of like batch and materialize this stuff once in 20 minutes or whatever you want to save costs or what is reasonable for you. And yeah, so the solution was before very simple. Store this data in Postgres.
The issue for Fresha was data freshness.
Yes, exactly. I mean, like, yes, it was an issue. So once the solution with Snowflake was delivered in production and everybody were happy, so now we can have like complex analytics. We can kind of like have even kind of a customer-facing analytics with some delay. But there were kind of like a lot of parts that were still not being possible to be served by Snowflake. So it was kind of, okay, we will find solution later. And like 3-4 years later, yeah, it was very painful, because imagine our main database where we do OLTP load, it kind of like sort of OLAP as well, because kind of like for homepage analytics, it was, okay, we need to get the data for kind of like 2 months comparison. So, and for biggest providers, it was timeouted, by the way, most of the time.
So yeah, OLTP for the homepage. And by the way, what scale are you working on? I mean, how many users, how many concurrent requests on this homepage?
I think like it's not that much. It might be kind of like 100 or maybe 100 per second. But it's spiky. It's another kind of like challenge, because imagine at the beginning of the day, all the kind of like partners want to check their metrics, or in the evening. And you need to serve it, and it should be kind of like responsive. Otherwise, it doesn't make sense. Then for the rest of the day, it's actually kind of like pretty stable. So it's also kind of like not an ideal situation for example, for Postgres, because Postgres relies on actually getting data from buffer cache. So if for the whole day your buffer cache was kind of like getting all the different information, and then suddenly you need to run an analytical query, you need to fetch it from the disk, and suddenly it becomes slow. And the bigger the provider, then the more data you need to fetch from the cache. That was the idea. And we kind of like thought, okay, maybe let's introduce ClickHouse, because like ClickHouse is a classical solution for this stuff. And I have a pretty kind of like long story with ClickHouse. I love this tool, but at the same time, I know that it's not very kind of like suitable for Fresha style analytics, because sometimes there are kind of like 30 joins, 40 joins, because as I said, like before it was BI analytics. In BI analytics, you can create very complicated like models, and you don't care about the amount of joins, subqueries, and other stuff. But once you move to real-time analytics and kind of like some warehouse, then you need to support it somehow. I mean, like usually it comes like, okay, now we need to do a different data modeling for our ClickHouse instance, which makes sense. But if you are kind of like a small team of data engineers, you don't wish to get into this kind of like hole. So that's why StarRocks. I mean, like it's absolutely suitable for joins, and the pattern I want to emphasize is actually pretty sensible. You just get like your query that works like with your Snowflake, BI analytics, and whatever, translate it directly to StarRocks. If it works, then you are kind of like fine. If not, you have a baseline metric from which you can assess like how much you can improve. Does it make sense? Is it kind of like feasible, this amount of joins? Kind of like, can you do 3 joins with Flink and other stuff? And because before, I imagine you're kind of like sitting and someone asks you, okay, we need like 3 new dashboards or kind of like 3 new widgets. And you say like, well, most probably it would take like 2 months. And you're kind of like just guessing into kind of like thin air. But once you kind of like can literally build this kind of like query with StarRocks like in 1-2 days, well, I'm exaggerating, but still kind of like very quick. Then you can say like, okay, I will return to you in 5 days and say like, kind of like how much time it would take to actually kind of like make it working with SLAs that you are asking us. And for me, it's kind of like predictability and sensibility.
Yeah, very quick iteration, and I mean the problem of ClickHouse is that it doesn't do well with complex joins, right? And
Yes.
StarRocks has really good support for that. I don't know that much about StarRocks, but I understand that you have these broadcast joins and collocation and like free core strategies to to solve the problem of shuffling, right?
Yeah, I mean, like the idea of StarRocks, it has a cost-based optimizer, like really advanced. You can really reason how you can execute a query to make the maximal benefit of the execution engine. With ClickHouse, they still they kind of like introduced cost-based optimizer, but still experimental. And I think like if you spend like 2-3 years just kind of like optimizing cost-based optimizer, then you're kind of like having an edge between, with the solutions that just kind of like introduced. So
where are you right now in the transformation? Like you were on Postgres at some point when and where are you right now?
Okay, so the transformation, I think like it started like almost 1 year ago, because I was we were still kind of like getting this problem. I just finished like a big project with Postgres zero-downtime migrations, and I was sitting and kind of like reading something about Pymon, something about Fluss, and I kind of like, wow, that's cool. I mean, like that's probably would help us to solve this problem. And I said like, okay, maybe we can introduce like lakehouse to have a canonical data representation. Then we can connect something like lakehouse. Then we need Flink, Spark, like classical tools to transform the data. And slowly we would get to the shape of data engineering that I would wish to operate like a modern stack. Then suddenly I discovered StarRocks and I said like, wow, it's kind of like a ClickHouse on steroids with joins. Let's try it. And the thing is, usually when kind of like I try the tools that I never heard about, it has a lot of issues. I need to do a lot of discoveries. With StarRocks, it just worked, and I was really surprised. For me, it's kind of like a story about like product is actually ready for kind of like usage. It's just kind of like a marketing and kind of like adoption story, and it's kind of like a right fit for us. So as I said, like it started like this. StarRocks is fully integrated right now at Fresha. Kind of like more and more teams are using StarRocks. I actually getting lost like tracking where StarRocks can fit, because first it started like, okay, let's solve the problem with homepage queries. Then it was kind of like, can we use it for
this was the big one, right? This was the big painful problem.
Yeah, it was a painful problem for me because I was responsible for Postgres databases mainly, and I saw it and I said like, can we do better? Can we do pre-aggregation? And it was constantly like, product teams are kind of like developing features. They don't have time for solving like this problem, and this problem was kind of like accumulating, and it was bad for reputation and also bad for Postgres. So I mean, like the idea was just kind of like to save Postgres from my side. Then it became like a much bigger. And right now it's kind of like I just created a modern data stack to do, like the style of work. When someone comes to me, I don't like to answer no. I want to answer yes, but I need to use Flink, but I need to use Spark, but I need to ingest the data into StarRocks, but I need to optimize joins in StarRocks. So I need tools. And kind of like Snowflake, Debezium, and Postgres is not enough tools in modern data world,
Yeah. And do you remember how long it took roughly from the moment you started considering StarRocks to the moment where there was actually a decision that we're going forward with this, and the moment it was running in production? What was the time roughly? Weeks, months?
Decision. Oh, I remember how it all started. I mean, like I just tried Docker container and I showed to Emiliana, our head of data engineering, and he kind of like, okay, what is it? And I said like, don't you see? I'm using MySQL protocol, like driver, to connect to some modern analytical database. And I said like, imagine what if you would kind of like build this solution, and we say like, teams, you don't need to actually learn anything like new to introduce like ClickHouse driver or whatever. You just need to have like MySQL driver. You write SQL query, and suddenly it magically works. So that was kind of like one of the selling points. It kind of like seems minor, but at the same time, it's actually very important. You need to care about adoption. So I think like partially the decision was made that time, but also, I mean, like there were a lot of doubts. I mean, like Fresha usually prefers to operate on something like, okay, we need this tool, let's buy it. something like this, because it's just kind of like quick. For StarRocks, I mean, like it's kind of like a big investment, so I was not entirely sure about like is it a good fit. Architecturally, yes. Operationally and other stuff, I didn't know. So I said like let's try to deploy it on our Cadis. Once it was deployed on our Cadis, and I quickly tried first, I think like my idea was, okay, let's try it with Pymon. It worked. And then kind of like for homepage analytics, the idea was kind of like, okay, let's try it for kind of like the biggest, in the hardest scenario, like updates every 5 seconds or something like so. Because in StarRocks, you still need to batch and only then to write to the actual like storage. Like in ClickHouse, for example, because if you write row by row in ClickHouse, you would get like an awful performance. So yeah, that's how it all started. And I think like it was only like 3 weeks until we actually thought like, okay, StarRocks is actually a good idea. Because once we got it deployed on Cadis, because our biggest fear was, okay, would it be hard to deploy with Cadis? And then there is an operator. I mean, like it has some bugs. It has a learning curve, but once you deploy, it's literally kind of like you just need to operate better, kind of like understand how it works, and that's it. So once we tried and queries worked, we said like, okay, but so it was weeks. Then we spent some time to actually kind of like polishing the architecture, and then I just said like, okay, let's try homepage analytics queries because they're ideal. Let's try it in the dumbest way. Let's try just to go and query. Let's ingest all these tables like as it is, without any optimizations, without any thoughts, and let's try to model this kind of like query like they are modeled in Postgres. We did it, and then I spent kind of like I think like 3-4 hours to integrate in a Ruby application because this homepage is kind of like some legacy Ruby application. So I introduced like MySQL driver and other stuff, and it just worked. So I created a feature flag. I think like I spent a lot of effort with actually creating feature flags and other stuff than to actually connect to StarRocks and run this query.
I mean, this is what production, making it production ready means, right? So,
yep.
So okay, there was a decision, and it sounds like from this until production deployment, you had like a few weeks.
Yes. I mean, like it was literally quick. So as I said, like it all started like as a transformation story, like 1 year ago. So we spent 2-3 months with kind of like introducing Flink, Spark, and other stuff. And then once we were comfortable, data lakes, also kind of like we tried Pymon, we tried Iceberg, kind of like. We spent some time to choose actually REST catalog for Iceberg. It was a whole kind of like 2 weeks project because it was very hard to decide because at the time Nessie was being closed. Yes, because imagine kind of like when you look on the surface, it's kind of like, okay, it's a minor thing. And then there are kind of like 10 different kind of like offerings in a different state. By the way, we at the end we moved with Lakekeeper.
So you arrived at this stage, like you evaluated quickly and introduced this into production quickly, and it sounds like it gave your team a lot of mandate to experiment with other things.
Yes, exactly.
Right. You got promoted in the process, as far as I understand. Yeah.
Yes, exactly.
Yeah. So apparently it's not just what you're talking about outside, but the organization appreciate this a lot as well.
Yes.
So what are you experimenting with? What other things are you adding to the stack? What other problems are you solving?
Mm-hmm. Okay, let's basically reiterate what we achieved. So it's a modern data platform. So we have everything covered from ingestion, transformation. So transformation is Flink Spark, to actually kind of like querying and kind of like using different kind of like syncs. So from StarRocks to Iceberg, like whatever you want, Elasticsearch. What is actually missing in this part? For example, we are operating on MSK. Mm-hmm. And MSK is kind of like a managed streaming for Kafka, because a lot of people actually ask what is MSK, and it's not working great, to be honest.
Why?
It's kind of like has a lot of limitations. I mean, like every security upgrade that they make on 17th or 19th of each month, it actually causes a cluster rebalance, and we have a lot of alerts. Okay. So this is kind of like one of the reasons. Then multi-AZ costs as well. So it's just like classical Kafka without a lot of kind of like ops added. and right now it's not very suitable. And there are a lot of limitations about the number of partitions and the amount you pay, because I'm using like Flink to do some transformations, and I need some intermediate topics. With kind of like MSK, I need to scale my cluster. I mean, like, I want some more elastical solution, and I don't want to receive alerts in kind of like every month at 17th or 19th. I just don't remember the date. Sorry. But yeah, the idea was, okay, I think like our team evaluated the options to replace MSK for 6 or 7 months. I was not involved in this. I was kind of like closely working with this real-time modern data platform. But then the solution was kind of like, okay, should we use Confluent? Should we use Ivan? And there were a lot of conversations, a lot of like marketing talks, and it was very confusing. And in the end, there was no really decision. And for me, it was kind of like, okay, but in order for my platform to operate, I need like some reliable ingestion, kind of like messaging layer. And I don't wish to think about partitions as like cluster instabilities and other stuff. So I got involved into this, and I literally discovered like AutoMQ. And AutoMQ is currently being put in production at Fresha. A little bit of context. At Fresha, we have two clusters of Kafka. One is used for CDC and basically for data platform. So you just kind of like getting data out of Postgres and providing through Debezium to Flink and StarRocks, Snowflake, whatever. And another cluster is Outbox cluster, where you need like lower latency. It's just like an integration layer between microservices. All good. But for example, once I discovered AutoMQ, it's kind of like diskless Kafka. And so diskless, it means like kind of like a higher latency. And it's actually kind of like a bit of a problem, because you don't wish to end up with two different Kafkas for different workloads. I mean, like, it's operationally kind of like not ideal. So when I assessed like solutions from Ivan and Confluent, WarpStream, and whatever, I mean, like WarpStream, I think like it has the most impressive architecture. It's really very elastic one, and yes, it's good. But for me, it's kind of like, okay, should I have like WarpStream for my Outbox cluster, and then kind of like for CDC warehouse cluster where latency doesn't matter that much, I should have like AutoMQ. And then I need to teach DevOps and other people how to operate and think about these different workloads. So for me, I think like the main benefit of AutoMQ is that it allows hybrid workloads. So I can have S3 wall for CDC warehouse, save a lot of money, and that's it. Because in order to prove that AutoMQ is a thing, I literally needed to, what I did, we deployed AutoMQ on our EC2s. Then Kafka linking was not working for us because it required SSL, because our cluster was with SSL support, and Kafka linking at this time, it didn't support it. So I needed to use Mirror Maker. And Mirror Maker, you know the story. It's kind of like a simple tool, but every time, I don't know, maybe it's just me. I forgot how to configure it, and then I just need to spend one additional day to just kind of like remember how to do it. So I mirrored all the traffic from our CDC warehouse cluster, and I watched the cost in S3. And it was like 17, 20 times less than our kind of like AWS cost. And then I showed it, and everybody's kind of like, wow, well, that's the thing. That's how I kind of like proven that we need to use AutoMQ.
Cool. How long does this experiment take?
3 days.
3 days. Awesome. So, putting AutoMQ aside, what else are you doing? What else are you working on, and what other problems are you trying to solve?
Well, my personal favorite is actually Fluss. Right now, actively kind of like being involved in Fluss Rust client. So this is kind of like my personal, I guess, like interest, but at the same time, Fluss is actually contributes to the vision that I wish to follow for Fresha data engineering. So, for example, Flink state is a problem. I want to externalize Flink store. So, because imagine I have like 20 different pipelines, and all of them kind of like need booking stable. So you know the stories that I need literally kind of like is this booking stable in every kind of like state for every single pipeline.
I mean, you cannot share state between Flink jobs, right? That's the core issue.
Yes.
That Fluss is.
It's internal.
And with Fluss, you externalize it, and all of the jobs can work on the same Fluss table, right?
Yes, exactly.
Yeah.
So there is a separate kind of like notion, because Fresha wants to do kind of like a lot of kind of like investment in AI ML. In this kind of like conversation, I think like I need to mention Feldera. This is another big one for me,
Very interesting.
because Feldera, when I was kind of like assessing, and the idea was kind of like, okay, Flink is not very user friendly for non-Java developers, and kind of like, okay, in data engineering we know how to use Flink, but what if we say like, okay, we have like, I don't know, like 30 teams at Fresha, like, and we say like, okay, now you are kind of like allowed to develop Flink jobs in order to get your data in a form that you like into StarRocks, for example, to use in your, in, I don't know, like applications to serve some analytics if you wish. And there is a danger that people wouldn't get like how to work with Flink. So my idea initially was kind of like, okay, what other alternatives do we have? Just not because Flink is bad, it's just Flink is very feature rich, let's say, and this kind of like feature richness and low levelness, it actually scares people away from it. Unless you're a data engineer, of course, then it's kind of like your bread and butter.
But also incremental view maintenance is coming to StarRocks as well, right? But right now I think it's supported only for primary key tables.
Yes, no, not primary key tables, only for Iceberg. I mean, like, it's a beautiful story, in my opinion, because when I saw Feldera and I kind of like read the paper about like differential data flow and the BSP model, I said like, okay, this is very big. I think like in the next 5, maybe 7 years, a lot of kind of like warehouse engines, they would wish to support this because it's not good. For example, I'm working mostly with Postgres, so materialized view, I need to literally kind of like materialize it on demand. Kind of like I need to go and say like, okay, refresh this materialized view, and then it would be a huge query repopulating this materialized view and whatever. And no,
you don't want to write imperative code on how to do this exactly. You just want to say what do you need, right?
Yes, exactly. Because that's the whole point of.
If it's possible to build tools like this, then they will eventually push out the ones that can't do it yet.
Yes, and this is kind of like the solution. This is like a mathematical, correct, and efficient solution for this.
So, okay, that's all of this sounds really awesome and sounds like you have a really cool job doing all this and having the trust to do all this. I wanted to think about some conclusions or learnings that you've encountered on the way, because what I've heard so far is that you are iterating really quickly, and one lesson and very important one is for vendors to lower your barriers for experimentation, right? And this is super critical if you want to get companies to adopt you without this large process.
You should be ready to actually kind of like step in to dig into source code. And literally that what I needed to do a lot of the times, because when we were experimenting with Pymon, documentation is very confusing. It's very little. And I mean, like, you need to go to source code, try to stage experiments to prepare your local Docker build. And in order to iterate quickly, you literally need to be able to iterate kind of like quickly on your local environment, try the things. And that's actually related to the thing that you said. If you want a quick adoption, you need to provide the tools for people to actually understand what's going on, because you cannot just expect from engineers to come to kind of like C-level and say like, we want this tool. If you are trying to run something like and rely on iterating quick, you need to get your hands dirty. So your team should be ready for this. And it's kind of like a different, I think, like mindset.
And I think for building bleeding edge tech for vendors, the right way is build a production ready open source solution, and then coming from the success stories like yours, and then this can be further used to promote the managed services, which also could solve it, right? Because if you have experienced StarRocks engineers on support, this some of these issues could have been prevented, and also you can get someone else to get your hands dirty.
Yes, of course.
Yeah. Look, I think that we have way more than enough material.
I hope so.
Anton, thank you very much for coming in. I hope that this was interesting and useful, especially to organizations that consider this kind of transformation. Thank you very much.
Thank you. Bye.